Hi there and welcome to Mr. T's Maths. In this video I'll be showing you how to use the nth term to generate a sequence. I know some of you are probably already thinking, and what is this n thingy? Well, the nth term is basically something that connects the position with the term itself. So the nth term in this case 2n plus 1 is simply a formula that generates the term in each particular position. So what we need to bear in mind is that n stands for the position. Therefore, if we want to find the first term in our sequence, we take n to be equal to 1. If we want to work out the second term, n will be 2, and so on. So let's start with the first term. Let's write the formula, 2n plus 1 in this case. That means n equals to 1, so 2 times 1 plus 1 will give us the first term, which is 3 in this case. Now to generate the second term, we write down again the nth term, the formula, as we can call it. We can refer to it as a formula, as I said before. And we take n to be equal to 2 because we are working out the term in the second position. So 2 times 2 plus 1, which is equal to 5. Now to find the third term, we will have to take n equals 3. So 2 times 3 plus 1 equals to 7. And in the fourth place, n equals to 4. So 2n plus 1 and then 2 times 4 plus 1, which is equal to 9. So if we had to work out the 100th term, then n would be equal to 100. If we had to work out the 10th term, for example, n would be equal to 10, and so on. Alright, I'd like you to have a look at the difference between these terms, in the sequence. So this is the sequence 3, 5, 7, 9, and so on. It's an infinite sequence. As you can see, the difference between terms is always 2 in this case. Well, when we have a sequence like this one, where the difference is always constant, so the sequence grows in 2's, or it's plus 3 plus 3 plus 3, or it decreases by a constant value, for example minus 5 minus 5 minus 5 each time, then these sequences are called arithmetic sequences. Okay, so they do have a special name. By the way, for more content like this one, don't forget to subscribe so that you can be notified when new videos are released. Now let's move on and do these examples that I have here for you. We have to find the first 5 terms of the sequence with nth term 4n in the first case. So to find the first term, n equals to 1. Therefore 4 times equals 4. To find the second term, then we do 4 times 2, which is 8. To find the third term, we do 4 times 3, which is 12. The fourth term is 16, and the fifth term will be 20. So as you can see, this is the sequence 4, 18, 12, 16, 20, and just to point this out, this is an arithmetic sequence because the difference, it goes up in steps of 4. It always increases by 4, by a constant. Therefore, it is an arithmetic sequence. Feel free to pause the video and try these examples yourselves first if you want to. Alright, let's move on to the next example where the nth term is 2n minus 1. So 2 times 1 minus 1, which leaves us with 1. 2 times 2 minus 1, which leaves us with 3. 2 times 3 minus 1, which is 5. 2 times 4 minus 1, which is 7. And then 2 times 5 minus 1, which is 9. So the sequence, the first 5 terms of this sequence is 1, 3, 5, 7, 9. So, and as you can see, the difference between terms is plus 2, plus 2, plus 2, which makes this another example of an arithmetic sequence. And in this last example, nth term is 3 and minus 2. So for the first term, n equals 1. 3 times 1 minus 2 is 1. For the second term, n equals 2. 3 times 2 is 6, minus 2, which is 4. For the third term, n equals 3. So 3 times 3 is 9, minus 2, which is 7. For the fourth term, n equals to 4, obviously. So 3 times 4 is 12, minus 2, which leaves us with 10. And for the fifth term, 3 times 5 minus 2, which is 13. As you have probably already noticed, the difference between terms is 3. So the sequence increases by 3 each time. Okay, which makes this sequence as well an arithmetic sequence. So I hope you enjoyed this video. I hope you found it useful. Make sure to give a thumbs up on the bottom just below the video, and enjoy. Take care.